drama surrounding the launch of a nuclear weapon, they're usually thinking about some sort of tense face-off between two officers who don't agree on whether or not to launch, often spurred by some sort of garbled message or unforeseen circumstance that leaves those orders in doubt. But in reality, this is actually the least dramatic portion of the entire exercise. American nuclear missile crews, regardless of which leg of the nuclear triad they fall under, train ceaselessly to execute the orders to launch under any circumstances. If the codes match, missiles fly. What does keep nuclear planners up at night is how to make sure the shooters end up getting the orders to fire in the first place. Early in the Cold War, new and maturing technologies in warfare and communications led to some interesting ideas about how to get launch orders to alert crews no matter what. Simply put, communications underpinned the entire credibility of the nuclear deterrent. The Pentagon needed a way to make absolutely sure that no matter what happened to its command and control infrastructure during the opening of a nuclear exchange, the president's orders would be delivered. In the end, they decided that the best way to launch a bunch of missiles and set bombers flying was to launch a missile capable of delivering those commands. That missile was the AN-DRC-8 Emergency Rocket Communication System, or ERCS. In America, the only person who can give the go-ahead to employ a nuclear weapon in any circumstance is the President of the United States. Once the President gives the order to launch nuclear weapons, that message passes through the National Military Command Center to forces in the field in the form of an emergency action message. The EAM details what options under the nation's war plans are being executed, and once crews get an EAM and validated, there's no going back. Keys are turned, and weapons are launched. During the Cold War, U.S. war planners were obsessed with making sure an EAM could be passed to crews, often devising backups to backups to backups to ensure the Soviet Union knew America had a reliable nuclear deterrent. One of the backups, designed in the early 1960s, was the Emergency Rocket Communication System, to be used in the event that land and air-based command and control methods for relaying an EAM were unavailable. ERCS was essentially an automatic EAM transmitter that would be launched via rocket into a high-trajectory suborbital launch path. It would then broadcast a UHF radio message containing the EAM to any ground or air receiver within line of sight. Once it was launched, it couldn't be recalled. Even if all other communications were destroyed, ERCS would deliver the orders for Armageddon. Development of ERCS began in September of 1961, when Strategic Air Command, also known as SAC, issued a specific operational requirement during heightened tensions between the US and the Soviet Union, particularly over the threat of deploying nuclear weapons. Allied Signal Aerospace Communication Systems won the contract for ERCS, developed the AN-DRC-8 system, and integrated it with a Blue Scout Junior rocket for delivery into suborbital space. Up until this point, Blue Scout Juniors were used for launching scientific payloads for research projects and had no combat applications. 4 months after the contract award, the initial version of ERCS, known as Project 279, was finalized, and the first successful test launch of the system took place in May of 1962 at Vandenberg Air Force Base in California. However, during this testing phase of ERCS, SAC was already preparing for the Blue Scout Juniors portion of the program's demise. In June 1962, SAC proposed that ERCS be mounted on 6 Minuteman intercontinental ballistic missiles, as opposed to the Blue Scout Junior rocket, which was considered a system that could be vulnerable to attack. The Blue Scout Junior ERCS combination was technically a road-mobile system, with one rocket launched from a trailer and a separate manned command trailer that actually fired the rocket. One of the advantages of any road-mobile missile system is it is comparatively easy to hide, and being able to relocate them makes them difficult to target. However, once you do find them, they can be easily destroyed. Things like missile fields, on the other hand, are very easy to find, but attacking them and taking them out of play can take a lot of doing. SAC didn't want such an important fail-safe system to be easily eliminated, so they decided the best option was to harden ERCS by mating it with a silo-launched ICBM. This kind of concurrent development and shifting in priorities was not uncommon during the Cold War, as requirements changed constantly due to a combination of technical advancement and reactions to what the Soviet Union was doing with their strategic forces. So while all of this wrangling was going on behind the scenes at SAC, in July of 1962, Project 279 reached initial operating capability, with the deployment of 3 Blue Scout Junior rockets at sites around Omaha, Nebraska. The system became fully operational as a stopgap measure in July of 1963, while SAC awaited development and testing of the Minuteman-mounted ERCS. It's important to note that SAC recommended Project 279 to be eliminated in September of 1962, but still wanted to ensure it had the ability to launch ERCS while the Minuteman matured. This turned out to be a wise decision on the part of SAC, as the first successful test of the ERCS with a Minuteman missile wasn't until mid-December of 1966. During this test, the Minuteman II missile took an ERCS payload into space, transmitted its message along its pre-planned suborbital path, and then fell back to Earth. After further testing, SAC certified ERCS as fully operational in late 1967, with 6 Minuteman II missiles on alert at Whiteman Air Force Base in Missouri. The ERCS version that eventually made it onto the tip of the Minuteman II weighed in at 875 pounds and was around 8 feet long. Any ERCS-capable launch control center could program cassettes inside the payload with the specific message to be broadcast via the ERCS control monitor console. Once the ERCS comms payload separated from the launching missile and began transmitting, it beamed messages via multi-directional UHF antennas to stations on the ground via the previously programmed message. By 1967, ERCS was able to communicate with EC-135 Looking Glass Airborne Command Post aircraft, and later with the E-6B Mercury planes that took up the Looking Glass mission. Both of these planes are equipped with the Airborne Launch Control System, or ALCS. The ALCS can be used to send EAMs to missile control centers, or even remotely trigger a launch under certain circumstances. In an interesting twist, ALCS can also initiate the launch of ERCS missiles in the event the controllers on the aircraft detect that communications have been disrupted. In 1967, SAC tested this capability when an ALCS-equipped EC-135 launched an ERCS-configured Minuteman II from Vandenberg. The Minuteman II was the only ICBM to be mounted with the ERCS payload, and testing of the system continued through the late 1970s. In 1974, the Air Force lofted an ERCS into space, and Pacific Command was able to read a clear message signal for 22 minutes. By the mid-1980s, the ERCS fleet consisted of 12 missiles, with 8 to 10 of them on alert at any given time. However, all 12 missiles were powered down and removed in 1991, following President George H.W. Bush's decision at the end of the Cold War to remove American strategic forces from their high alert status. Of course, any discussion about American strategic posture during the Cold War isn't complete without discussing what the Soviet Union was doing at the time. The USSR developed a similar system as ERCS, referred to as the perimeter. While specifics are a bit sparse, during the Cold War, perimeter was considered to be a dead-hand system that could automatically launch a retaliatory ICBM strike without any human interaction, even if the Soviet leadership was wiped out. We know now that perimeter operated somewhat similar to ERCS, and was used to transmit launch commands via rockets with communications payloads to strategic forces awaiting orders to fire. Like ERCS, it also required a human to initiate the launch of the system. While ERCS is no longer functional, and the Cold War is over, the need to communicate with strategic nuclear forces under pretty much any conditions imaginable still exists. The U.S. still retains the ability to remotely send launch orders to control centers in charge of Minuteman III silos via the ALCS on the E-6B Mercury, which can also transmit orders to the Navy's Ohio-class ballistic missile submarines. As for the future of the ALCS remote launch concept, that's still up in the air. As the E-6B Mercury enters the twilight of its career, the U.S. Navy is looking to field a new system, based around the C-130 Hercules, to take over its share of its mission, giving orders to nuclear ballistic missile submarines. However, those C-130s will not have ALCS, or be configured to support the Air Force's Strategic Looking Glass Airborne Command Post mission that works with the Force's ICBMs. As for the Air Force's part of the solution, the replacement program for the E-4B Night Watch Airborne Command Post, better known as the Doomsday plane, is underway now. This new aircraft will be based on the 747-8I platform. E-4Bs once had an ALCS capability, and the Night Watch community could regain that with this new aircraft. Replacing the 4 E-4Bs with a larger fleet could allow the type to take over the Looking Glass mission in full. A greater focus on space-based communications will also likely be part of the solution, which could see the ALCS component eliminated altogether. Although the ERCS thankfully never needed to be used operationally, it constituted a fascinating piece of engineering and stood as a small but unique solution to the darkest of communications and command and control challenges.